I'm here to talk about security, so I hope you guys are excited to talk about this topic in the morning. I'm here with Arun from Vormetric, so maybe Arun, you can introduce yourself as well.
Sure. Yeah, so I'm here with Vormetric, and we're here to talk about data security for Couchbase. So how many people like it when a security compliance auditor walks in with a request to? Probably not too many. So that's, we're here to talk about that, what drives some of their behaviors and how we can help you guys address some of those requirements specifically. And I've been at Vormetric for a couple of years, work on technology partners, and Couchbase is one of our big partners in the NoSQL space. So looking forward to this session and sharing some best practices and techniques with you guys.
Cool. So a rough agenda for this talk is going to be talking about, I'll start with talking about giving you a Couchbase overview of why security is important for NoSQL databases. It's quite a hot topic nowadays. And also some of the key drivers for security, why a lot of you may be asked by, let's say, a chief security officer or other, let's say, IT staff within your organization to kind of enforce security. And then I'll pass it on to Arun to kind of explain how Vormetric works and how our joint solution works with Vormetric to kind of encrypt your data. So with that, so why is NoSQL security important? So with all these sessions that we had yesterday and even many of them today, you probably noticed that we're talking about performance, we're talking about multi-dimensional scalability, and all these great things that we've done within Couchbase Server. So a lot of these things give you things like enable you to handle data with coming in with a high volume, definitely with a high velocity as well, because you have data from different sources at high speeds. And finally, variety. The fact that you are using a NoSQL database is because you also have data coming in with different formats or different fields, and that's why you use JSON as the underlying data format. But in addition to all of this, if you look at just sample a lot of apps today, you'll see a lot of apps process a lot of unstructured data. And when we talk about unstructured data, we mean emails, videos, tweets, posts, all kinds of data which have so many different attributes and fields which are also constantly changing. And so one very important property of your data there is value. So your data is also valuable. You might be storing sensitive information in the data, and that's the last, I would say the 3 V's, and the last V is the value there, the 4th V. So when we kind of sample the field and we're talking to customers, we see what are the common security questions we asked. And I think in my presentation yesterday, we kind of talked about some of the controls that Couchbase has internally to kind of answer many of these questions. So some of the common questions that we get from our customers are, which ports are open through the firewall? What vulnerabilities exist? Is there any admin data separation? Is your data encrypted in the cloud if you're just backing up data in the cloud or just using running Couchbase in the cloud? Is XDCR secure when you're putting data across to another data center? Is sensitive data encrypted? Or even backups encrypted, or what if an operator steals a disk? So there's so many different questions that we get, and what we're here to answer, I think the red ones are the ones we kind of talked about yesterday, but what we're going to answer through Vormetric and our solution with Vormetric is the ones in blue. So with that, I'll just pass it on to Arun.
Great. Thanks, Don. So first, let's do a little bit of setup here. So, I think Bob, a couple of days ago, talked about the digital economy and data is exploding, and the subset of that data is very sensitive data. And if you think about the digital economy, the new disruptive companies and some of the legacy companies, they're very high attach rate to deploying in non-traditional areas. So typically, data was located in enterprise data centers, remote offices, but now they're going to public-private hybrid clouds. They're also people using big data to go, proliferate information there, and there's lots of it. I mean, I think it's pretty obvious. There's a lot of data being out there, and part of it's sensitive data, and there's mandates around protecting that sensitive data. And so let's take a look at a couple of the specific use cases, or double-click on cloud and big data, and this is analyst data we collected. So if you look at one of the biggest concerns for deploying workloads in the cloud, it's data privacy and security. So large enterprises, customers want to make sure that they have that data locked down if it's going to be in a public cloud or private cloud or hybrid cloud, and data security is one of the top concerns. The other one is big data. I mean, so big data is very agile. You get a lot of information. You can do things very quickly, But one of the biggest growth inhibitors, again, is security and privacy. And a lot of times, when I talk to our field guys, it's ex post facto. People went through a really good app. They're going to deploy it out in the cloud. They're using Couchbase, but then there's a fire alarm that goes off that said, we can't put this in production until we protect it. So a lot of times, it's done at a last minute or ex post facto of doing everything. So, one of the things hopefully we can leave you with is try to make your jobs easier by baking it into the part of the process. And I think we can talk about a couple of techniques about doing so. And then, again, as this data set moves out to the cloud and to big data, some of the traditional IT security challenges don't subside. So how many people in here have heard about Anthem, Target, Sony Pictures Entertainment? The list goes on and on and on. So what we're seeing in probably the last year, executive mandates around thou shalt protect sensitive data, and sensitive data in this case could be PII, privately identifiable information, could be personal health information, and if you look at HIPAA, it's very prescriptive around what needs to be protected, and then also intellectual property, et cetera. So there's a lot of executive anxiety that's manifesting from the CISO to the CIO to a lot of folks in this room on being able, thinking about security. And what's driving that again is nobody wants to be the next big headline, go into lawsuits. I mean, I think I looked at the Target, they're still in litigation. So it's a long and ugly process. So they want to put some controls in place to help mitigate that. So again, compliance is still going to be a big factor. So PCI is very prescriptive. HIPAA is very prescriptive. And they're also, I guess the other thing that gets taken into account is state regulations around privately protecting data privacy laws. So California has a data privacy law, Washington, et cetera. And some of these are very punitive the fines range based on the amount of data that's exposed or breached. So again, all this stuff still exists whether you're in the cloud or you're deploying workloads in the cloud or using big data, and that won't go away. And how many of you guys are familiar with this company FireEye? So big in the data breach space, but one of the other kind of attack vectors is if you ever listen to Kevin Mandia speak, I think he was on 60 Minutes, a great speaker. One of the other big threat vectors is the insider threat. So if you think about when data gets stolen, it's either a rogue insider or it's a malware or a piece of APT. And what they go after is those root accounts or privileged user accounts that have access to godlike access to data. And that's where they kind of glean all the stuff. So that's another big thing to think about, and then I'll talk about that. But that's a big source of data breaches and why people are getting hacked. So if you look at, this is kind of the Vormetric-centric kind of slide, but sensitive data is not just in NoSQL databases. It's also in structured databases, unstructured data. Imagine if you call up your healthcare company, they say ask your name, your social security number. All that stuff's being recorded and stored somewhere, and it's all sensitive data. So, example of what unstructured sensitive data looks like. So basically, there's multiple use cases or multiple places where sensitive data is deployed, and so we have the ability, again, using a centralized management platform to address multiple encryption use cases, because it's not just going to be Couchbase. Maybe you have some other structured databases somewhere, a data warehouse somewhere, et cetera. So we have the ability to, on an enterprise-wide basis, to address those encryption use cases. You probably don't want a separate product for each single use case. And so we have multiple techniques to do that. And if you look, so we're going to talk about, there's two techniques we're going to talk about today. Transparent encryption. That's where basically there's no changes to the app or to the database, and that's why it's called transparent. And then field level encryption or app level encryption. These are probably the two techniques we've seen very common with Couchbase and NoSQL in general in being able to protect data. And then we also have, I think Don put up dev and QA, so we have the ability to redact private information. So if you have data that goes from dev to QA, but maybe has some sensitive information, you can tokenize that data. That's another way data analysis is done. So in a nutshell, I think we help address multiple use cases, and we'll go into a couple of those today. I think I covered topic one, where what is sensitive data and where is it located in multiple places, and we talked a little bit about topic two. Actually, I think I covered most of this, but we can. So I'll just skip past this one right here and go to. So first we're going to talk about Vormetric transparent encryption. So this is really, as developers or as folks that want to have least intrusive encryption, this is probably the trade-off here is it's really quick to implement, and it encrypts data and it shuts out to OS privileged users. So I'll go into this a little bit more detail, but that's a benefit to this. So again, the reason we call it transparent is there's no changes to the application or database. So I'm going to look at this in 2 layers. So the first layer is the architectural layer, and the second layer is a policy layer. So from an architectural perspective, hopefully you can see that dotted line here, but this, the way we have a hub and spoke architecture. So on the left-hand side, there's a data security manager, or DSM, and this is really where the security policy is owned and the keys are stored and the audit logs are stored. And so that basically prescribes under what criteria data can be accessed. On the right-hand side, there's a box that represents a server. In this case, it could be a Couchbase data node, which includes indexes and data, et cetera. And so we're deployed, if you look at that V with a circle, it's actually an agent that sits at the file system, and it actually implements a policy that's dictated by the data security manager. And essentially, what we do from an architectural perspective is we're sitting at the operating system of the file server that's connected to persistent storage. And so we're transparent to the database, we're transparent to the application, and so so basically, there's no changes to the database, no changes to the application. You basically get the encryption up and running fairly quickly. And so from a file systems perspective, or a file server perspective, we support Unix, Linux, Windows, all the major operating system. And on the storage side, we support multiple file system types, and those are 2 big dependencies. So in a Couchbase context, this could be a Couchbase data node, and that agent is enforcing the policy from that data security manager. And so one of the biggest questions we get asked still continuously is, encryption's a math problem. How's this going to impact my performance? It's great, it's transparent, I don't have to make any changes, but is it going to impact my performance? So we basically work with Intel, which is another company here, and we offload a lot of crypto functions to the hardware. So they have something called AESNI, so you can hardware optimize the encryption and key management. And so typically, the mileage is going to vary, but typically we see about less than 5% impact. So again, so the application user is not going to feel it, that it's in the background, neither is the database vendor. So, it's really optimized performance, and some of the performance kind of concerns have gone away, but that used to be there. Now, if you look at basically the policy layer on this, so we're looking at essentially three population sets. So one is an OS privileged user. The second is a Couchbase process and service user. And the third, on the right-hand side, is suppose this data is out in the cloud. The other population you need to be concerned with is cloud administrators, storage administrators, et cetera. Because if you put something in Amazon, there's administrative users that have access to the data to be able to do what they need to do. And so so basically, for a Couchbase process and server, they have a legitimate use to the data, their intended user. So essentially, you allow them access to the data, and then you decrypt it for them. And essentially, they can do their job and go along their way. On the OS privileged users, these guys have a legitimate access to the data because they need to do their backup job or whatever, but they shouldn't be able to see the data. So you can allow them access, but you blind the data to them. So literally, all they see is ciphertext with some headers that allow them to kind of do their job, but not yet see the data. It's probably the biggest scenario this conjures up is Edward Snowden, right? He was an OS system admin. So he had full access to data. He could view it, and he could copy it. He could move it, do whatever he wanted. But the fact that he could actually see the actual data, that was one of the big vulnerabilities there. So and again on the cloud, you can think of that an extension of the OS privileged user, where again you give them access, but you blind the data. And we refer to the time as blinding data. And so basically, and if you kind of loop this back to one of the biggest threat vectors to data breaches, it's that OS privileged user and the fact that they actually have unfettered access to data. And again, but they're not an intended business user. So how do you solve that problem? And again, this is one technique that you can use to do that. And additionally, from a Couchbase context, it's not just the data nodes that have valuable information, but if you think about reports, configuration files, logs, sometimes that's even more valuable than the database files themselves because they contain aggregated information. So be able to protect all that information. So essentially and then the other big thing is we offer, you want to have the key separate from the data. So we offer so the data security manager here is providing key management. So the key is residing separate from the data. So if you think about it as in cloud context, you're a company that owns a security policy and owns a key, but your workload's out in the cloud. So you explicitly can dictate when somebody can access and view the data because you own the security policy. So a lot of customers, like this, and because they can deploy stuff out in the cloud. And again, going back to one of the inhibitors of cloud, it's data privacy and security. And cloud is, whether it's cloud providers directly or SaaS vendors, it's a huge driver for our business. And the other one I think Don talked about yesterday was audit logs. So the ability to capture all this granular information on who's accessing data and what they're doing, we can feed that into any SIM of your choice or a Splunk dashboard. So you can look in, a lot of times that's what the security folks and auditors want is reports and alerts. I mean, the fact that you're actually monitoring that data access. So that's our what we call transparent encryption, and it's also known as file level encryption because it's a file layer, and it provides that not only encryption but that ability to shut out the OS privilege user or blind the OS privilege user. All right, so next I'm going to talk about application encryption or field level encryption. So here, and so Don talked about separating admin access from data access. So this addresses that part of it. So essentially, you kind of move that agent up from the file system to the application. And what you do is you can encrypt certain fields of data, just pick, say, social security number. Say an application makes use of social security number or some other data, but they want to encrypt that. So essentially, the agent would sit at the application layer, and using a PKCS11 library that we have available on that data security manager, you can make calls to that and encrypt certain fields of data. And this is what's called field level encryption. And here, it's what you're doing again is you're blinding the database user as well, because it's the application that's determining that's actually doing the encrypt and decrypt. So you kind of from a security perspective, you're raising the level of security you have essentially. And so basically, it works pretty much the same way, except you're doing the key calls there. But here's an example. So this is with Couchbase. So this is a Couchbase using a Couchbase client. So essentially, if you look at the animation, you have an application that calls using an API. Again, it's a PKCS11 API. Makes calls to the data security manager to encrypt certain fields of data to get the key to encrypt it. And then when it sends the data back to the Couchbase server or the Couchbase client, and it's encrypted at that point. So it's encrypted in the database layer as well, in addition to the file layer. All right. So next, let's take a look at how this goes into practice. And so I took some screenshots of our GUI, and I'll show you kind of the scenarios we talked about. And again, the three population sets that I referred to earlier, which is an intended user, say it's a Couchbase process, a privileged user, an OS privileged user, and then third is anybody else. It's basically any unauthorized user in general. So if you look at, and this is pretty much a rule set that most customers have. It's very simple. People typically have anywhere from 3 to 5 rules, and essentially, if you look at it, it almost looks like a firewall. For those folks that are familiar with firewalls, you have a set of criteria, a resource, a user, and again, we integrate with LDAP and AD, so we pull the user groups from there, and then you can bind them to a process, saying this user using this process, allowing them to and under this action, what's the effect? So that you define a criteria and the effect. Again, the two main effect points are: do you allow them access, permit them, and do you apply a key? Do you allow them to actually see the data? And so essentially, that's what you apply is a criteria. I mean, the effect from the criteria, and you can get very granular with this. So you can, you can make sure that you literally dictate the level of trust you have for people to view and access data. And so then there's an intended user, and then privileged user, et cetera. I'll go into this a little bit more detail, but I just want to give you an overview of what the typical rule set might look like. And again, this works in a Couchbase context as well. So here, I mean, what do you do? Typically, what you do is you define a user set list, right? So basically, we create 2 user set lists. One is a Couchbase-centric one, and another one is a root one. We talked about the OS root level user. So essentially, you create 2 user lists here. And then what you do is you define some criteria and what the effect is here. So again, for your intended user, you permit them access, you apply a key. Your privileged user, you permit them access, you don't apply a key, you blind the data, but then you audit everything they do. And one of the other threat vectors to think about is sometimes root users, and especially APTs, try to escalate privileges to become an intended user. That's a real common threat vector. I'm going to go in as root, I'm going to escalate my privileges so I look like a legitimate user and try to grab the data. So we have the ability to stop that and alert on it. So we're root aware, so you can't escalate your privileges if you're using our policy or our agent here. So here maybe you want to audit everything they're doing just to see what's going on. And then the third line is anybody else. So anybody else is trying to access the data, you just deny it and you audit it, because if there's an unauthorized user or process trying to access data over and over again, you probably want to probably something suspicious, unusual going on. So you have the ability to stop it and audit it. Excuse me for just a second. So once you define a user set, user group, and then a policy, you can get very granular on where you want to apply that, what we call a guard point. So a guard point is that policy set, and you can choose where you want to apply. Do you want to apply to a file, a directory, the entire disk? Because maybe not the entire set of data in a storage pool where this is being pointed to is sensitive. Maybe just a subset is. Here, you look at the Couchbase example, right? The data files, the binary files, config files, et cetera. You can designate which path you want to protect, and so you can get very granular. And the biggest use case is maybe not all data is sensitive. Maybe this data is mingled with other data and some other type of application or database. So again, you can get very granular on what you want to do. And then one of the things you can do is this is really what enables encrypted backups. It's one of the problems that Don talked about. But again, if you have OS administrators that all they do is back up data, guess what? Now they have the ability to back it up, but it's just encrypted, A, and then B, you can send that data to the cloud or any other place, and it's all encrypted. So a lot of our customers do encrypt DR, but they use us to encrypt the data, but they can put it on Amazon or Google, whatever cloud of their choice is, and the data is encrypted, and they own the keys. So even if they want to move from one, say, cloud provider to another, they basically have the key and just can destroy the data. Nobody else can view the data. So it's it's a good way to be able to protect the data and not be locked down to a cloud vendor and move workloads around. So now let's, again, going back to the population set we talked about. Let's take a look at this. So this is the Couchbase approved user. And here you see that they get access to all the data. They can see the metadata. They can see the actual database data, et cetera, and they can do their job. And we have pretty granular logs. I'm not going to ask you to read all the text down there, but basically it audits all the activity that's going on. And this second one is an example of a privileged OS user. You see, what's different is, again, they can see some of the headers and some of the metadata, but they don't actually, it's all ciphertext. So again, this ability to access it, but not actually being blind to the data. So again, if these guys need to do backup or any other thing, they can do it, but they don't actually get to view the data. They can't copy it, et cetera, to do bad stuff with it. And the third is obviously very simple. It's any unauthorized user that doesn't meet the criteria you define for either accessing or viewing the data. They're just denied. And essentially, they just you can log this and send it off to whoever might be concerned about this. So that was the meat of the presentation. And so just to summarize, I think we heard all the sessions today. The reasons people use Couchbase is a really powerful NoSQL platform, very high performance, and performance again is not just Couchbase, but all the other parts of the ecosystem they interact with. And so again, we want to, from a transparent encryption perspective, try to make it transparent as possible, not only for a development perspective, but from a performance perspective. And as I talked about earlier, data security is huge, or protecting data at rest. That's the typical. If you use a Verizon report or a FireEye report, that's where a lot of the theft is happening, when data is sitting at rest somewhere and somebody's got access to it they shouldn't have, and so. This is what's driving a lot of data breaches, and so our advice is to address it proactively versus doing it reactively. We see this all the time, and then we've partnered with Couchbase to help optimize our integration with them, and we do performance testing, et cetera. So try to make this as easy as possible for you guys.